Welcome back to Physics with Miss B, and today we're doing drawing ray diagrams. So we want to start with the principal axis, which you see I am darkening right here. And then we're going to draw the lens, which I'm also going to darken. So you want to have those two. So the lens is perpendicular to the principal axis. Principal axis is in purple, lens in green. Okay, so I'm drawing the focal length, and what I did was find the same length using the same arrow to place my focal points. Using the same arrow, so twice the length of the arrow, I'm about to now place a point that's going to represent twice the focal length. The arrow that was just placed on the focal point is going to be called the object. So in drawing ray diagrams, we want to determine if the image produced by the lens, well in this case the lens is a convex lens, if the image is going to be real or virtual depending on where it is placed. So I'm labeling it. So we have lens, and we have the focal point being labeled as F, and twice the focal point, or twice the focal length, being labeled 2F. And that's the optical center, which we'll get rid of because we need space. So again, the distance between the green line and F is called the focal length. The distance between the green line and 2F is called twice the focal length. The first ray hits off at the top of the object, passes through the lens and into F. And the second ray hits off at the top of the object and passes through the optical center. The rays then conjoin to the left of the object. This indicates that we have an image that is larger than the object and that is virtual. Please note that these ray diagrams are only going to be involved, well, we're only going to use 2 rays. In some books you will see 3 rays. The 2 rays are enough to indicate where the object, where the image will form. Okay, so we have a virtual image. We're going to write some perforated lines. And that's the finished product. So this image will be formed usually when you use a magnifying glass. This is basically how the rays of light are behaving when you use a magnifying glass. And as you can see, this happens when the object is much closer to the lens. So it's in between the focal length and the optical center, which makes sense when you use a magnifying glass. Now we're going to move the object onto the focal point. The distance away from the lens, the focal length. So the first ray again travels from the top of the object through the lens and diagonally through the focal point. The second ray will pass from the top of the object and through the optical center. As you can see here, when the object is sitting directly on top of the focal point, the rays are parallel. They will never meet, so there will be no formation of an image here. If we extend the rays, we see they'll never meet. Our next diagram, we're going to place the object between the optical center and twice the focal length. Well, between the focal point and twice the focal length. Right. So we're going to draw the first ray again from the top of the object and diagonally through the focal point. And the second ray will pass from the top of the object through the optical center. And voila! Wow! We have an intersection happening there. And this tells us that the image that is formed is on the right hand side of the lens. Here the image is real, so once the image is upside down, as in inverted, the image is real. This image is something you would see formed by a projector. Okay, so now we're going to place the object on top of twice the focal length. Or we're going to place the object twice the focal length away from the lens. And again, we're going to draw two rays coming from the top of the object, passing through the lens. So the first one will pass through the lens and then diagonally through the focal point. And the second ray will pass from the top of the object, and we see a coincidence. So it coincides. So again, the second ray passes from the top of the object through the optical center diagonally, and then the crossover, and we see that the image again forms on the right hand side of the lens. It is inverted, as in upside down, so it's real. And it is the same size as the object. And it forms directly on 2f, twice the focal length. Okay, so now we're going to move the object to the left of twice the focal length. So this is further than twice the focal length, sorry. And then we're going to move the ray. The ray is going to come off the top of the object, same thing, and pass diagonally through the focal point. And the second ray will move diagonally through the optical center and they coincide again. As you can see, the image is smaller, it's real, and it falls between the focal point and twice the focal point that is on the right hand side of the lens. Okay, so if you're drawing along with me, this is what you should get. Okay, so now I'm going to draw a focal plane. This line runs perpendicular to the focal point. And we're going to explore what if a light ray enters the lens diagonally and passes directly through the optical center. That is where the lens and the principal axis cross, or form a cross here. We're going to use 3 rays of light to demonstrate this. So we're going to make sure that the length of the lens is the same on top as well as on the bottom. That's our third ray, second ray, sorry, and this is our third ray. What happens is that these 2 rays are going to meet up at the point, at the same point that the center ray is hitting the focal plane. Alright, hope you enjoyed. There you go. Make sure when you're doing these you use a ruler and a sharp pencil, and use nice white paper. Bye now.